Welcome grade 6 students to a new lesson where we're gonna discuss acids and bases. So we're gonna define or identify acids and bases and understand the difference between them, and also identify indicators, pH scale and pH meter, which are instruments that serve to identify whether a substance is an acid or a base, and finally to know some of the uses of acids and bases. So basically we have three kinds of substances. We have acids, bases and neutral substances. So these three substances could be identified by their taste. So acids have sour taste, and this is the first thing that comes into our mind when we hear the word acid. And bases have bitter taste, and finally neutral solutions have no taste. Okay, but this isn't enough. We cannot identify all acids and bases by their taste, simply because not every substance could be tasted, and some substances are toxic, so it's not neither accurate nor safe. But for now, it's a property of acids and bases and neutral substances, which is the taste. So acids have sour taste, bases have bitter taste, and neutral substances have no taste. So first let's start with the acids. So acids have sour taste, and the reason for this is that they release hydrogen ions in solutions. Remember, hydrogen ions are hydrogen atoms which lost one electron, their only electron, so they make hydrogen ion. So an acid, once it's dissolved in water, it will release hydrogen ion. Now it's just like dissolving sugar in water. The more sugar you dissolve, the sweeter the taste will be, and the more concentrated the solution becomes. So the same goes here. The more hydrogen atoms are released, the more or the stronger the acid becomes. So high concentration of hydrogen ions means the stronger the acid is. Okay, so strong acid or stronger acid means a lower pH, but we are getting ahead of ourselves now, so we're gonna define the pH later on. But for now, a strong acid means a lower pH. Some examples of acids: we have the citric acid. You can write the formula. Let me write it here again. So H3C6H5O7. We have also the acetic acid, like in vinegar, C2H4O2. So these two substances, if you dissolve them in water, they will release hydrogen ions. Now for the bases. So unlike acids, they don't have a sour taste, they have a bitter taste, and they feel slippery. You can try this. If you try to grasp a piece of soap, it will, slip out of your hand, because it's the property of bases. Soap contains base. So they don't release hydrogen ions, they release hydroxide ions. A hydroxide ion is a combination between oxygen and hydrogen with a negative charge here, so it's OH minus. Hydrogen is H plus hydrogen ion. Hydroxide ion is OH minus. So bases release OH minus ions in water. And the same goes here. So the higher the concentration of hydroxide ions means the stronger a base is, and this time the higher the pH is. Okay, so stronger base means higher pH. So it's like if strong goes up. So if a base becomes stronger, then the pH will also increase. Okay, so like bases that have a pH of 9 are stronger than a base that has a pH equals to 8. Okay, now many foods contain contain bases like green leafy vegetables, cauliflowers, broccoli. Okay, so many foods contain bases. So the uses of acids and bases. So acids could be used, and specifically weak acids are found in many sour candies. Vitamin C, ascorbic acid, is found in oranges. This is the formula of the ascorbic acid. Also, strong acids are used in production of plastic, explosive, fertilizers, textile, and paints. Okay, so now one more thing to note here. Okay, so nitric acid, HNO3, is a strong acid. Sulfuric acid, H2SO4, is also a strong acid. It's used in car batteries. Now, another example of the use of an acid is the use of hydrogen chloride. So hydrogen chloride is used to break down food during digestion, but since it's a strong acid, so to protect our stomach, our body has a mucus lining, okay, so that this strong acid does not dissolve or damage our stomach. Now, one more thing to note about acids. So let's note this one, HCl. It starts with hydrogen. Let's take another one, HNO3 starts also with hydrogen. H2SO4 starts with hydrogen. So most acids start with hydrogen. So if you see like HNO3, H2SO4, so you can easily tell that this substance is an acid. And these substances release H plus or hydrogen ions in solutions or water. Now the use of bases, like strong bases, are used in batteries, and since bases can break down and dissolve substances, so they are used in cleaning agents because they are slippery and can break down and dissolve substances such as grease and oil. This is very important. Okay, so drain cleaner also uses NaOH. It's sodium hydroxide. So it ends with an OH, so you can tell that it is a base. Okay, and H3 ammonia is a weak base also. Okay, it's used in cleaning and bleaching. Now if you check page 55, so the use of acids and bases. So acids and bases have many important uses. So strong acids are used in the production of plastic, explosive, textile, like sulfuric acid, nitric acid, and hydrochloric acid are commonly used acids. And strong bases are used in batteries. Ammonia, which is a weak base, is used in cleaning and bleaching. Okay, but for safety, always remember not to taste any substance, and many substances like strong acids and bases must be used carefully. You must wear protective clothing and eyewear, so they are very harmful for the skin, eyes, and for your body. So this is why tasting is not enough. So we need some sort of indicators to identify the type of the substance. So identifying acids and bases, we have two ways. Either we use indicators or we use instruments such as pH meter. Okay? So let's start with indicators. Indicators, and these definitions are very important. So indicators indicate if the solution is acidic or basic. So they are materials that react with either acid or base and change color. So an indicator, we have a specific indicator for bases and specific indicators for acids. So they react with either acids or bases and change color, which is a sign of a chemical reaction, right? But do not react with neutral substances such as water. Okay, so these indicators are chemical materials that react either with acids or bases, and they change color accordingly. So like red cabbage juice changes color if you mix it with acid or a base. And we have the litmus paper. These are the most important indicators. And we have also the pH paper. So this is the third indicator for today. So red cabbage juice, litmus paper, and pH paper. Of course, litmus paper, there are two types of litmus paper, the red ones and the blue ones. We're gonna see what's the importance of each one. So first, red cabbage juice is a neutral indicator. So red cabbage juice reacts with both acids and bases. Okay? So if you take the red cabbage juice, if you mix it with a base, it will change its color into green. If you mix it with an acid, it will change its color into pink. Okay? So this way, if you have like a container of a certain solution and you don't know whether the solution is an acid or a base, so you can use red cabbage juice to tell whether it's a base or an acid. So if you add the substance to red cabbage juice, it will change its color into green if it's a base and pink if it's an acid. Now, what happens when you add a neutral substance to red cabbage juice or red cabbage? Simply nothing. Okay, so red cabbage juice, like any other indicator, doesn't interact or doesn't react with neutral substances. Okay, and one more thing about neutral substances. So we know that acids release hydrogen ions when dissolved. So if we have an acid, we will get hydrogen ions. If we have a base, we will get hydroxide ions. But if we have a neutral solution, either we get neither hydrogen nor hydroxide ions, or we get both but at the same rate. So like NaCl, if you dissolve it in water, it will give sodium ions plus chlorine ions. So neither of them is hydrogen or hydroxide. So this is why this substance is a neutral substance. Okay? Other substances like water, you have H2O. So follow me here. H2O, if you break it down, it will give you H plus OH minus. So in this case you're gonna have as much hydrogen ions as hydroxide ions. So this way they will, cancel one another, and the result will be a neutral substance. Okay. Now, litmus paper. As I said, litmus paper, we have two types of litmus paper, or two colors of litmus paper. We have the red one and the blue one. If you use the blue one, the blue litmus paper reacts only with acid. So it will change its color to red, but only with acids. If you dip it in a base solution, it will retain its color. Nothing will happen. Okay? Or of course a base or a neutral solution, because indicators don't react with neutral substances. So a blue litmus paper reacts with acid and it will change color into a pink. Now the red litmus paper reacts only with base and its color will change into blue. So it's kind of exchanging colors, okay, from blue to red. So acids turn litmus paper, turn the blue litmus paper pink or red. Bases turn red litmus paper blue, like this example. So if we use two litmus papers here, we have a red one and the blue one. If we dip them in a solution, as you can see here, the blue one didn't change its color, but the red one turned blue. So this means the solution here is a base, right? Because only base turns red litmus paper blue. This case we have a red one and a blue one. The red one didn't change its color, but the blue one changed its color into pink, so which means that the solution here is an acid. If you have a neutral solution, neither of them will change, so they will retain their original colors. The red one stays red and the blue one stays blue. So litmus paper react either to acids or bases, but not to both. But red cabbage juice react to both acid and base. Okay? So again, litmus paper and red cabbage juice indicate if the solution is acidic or basic, but it does not tell now how strong or weak an acid or a base is. Okay? So as you know, the higher the concentration of hydrogen ions, the stronger the acid is, and the higher concentration of hydroxide ions, the stronger the base is. So we can use these indicators to tell whether a substance is an acid or a base, but we cannot use them to tell how strong an acid or a base is. Okay? So to do this, we need to use something called pH and pH scale. Okay? So pH it's like any other scale. So it tells how strong or weak an acid or a base is. So the degree to which a substance is acidic or basic is referred to as its pH. And pH measures the strength of acids and bases, and it goes from 0 to 14. So let me find first the midpoint at 7. So as I said, at the beginning, the higher the concentration of hydrogen atoms is, means the stronger the acid is, means the lower the pH goes. So at low pHs here we have strong acid. And the same, the higher the concentration of hydroxide ions is, means the higher the pH goes. So at this area we have strong bases. So this is supposed to be the acid area. This one's supposed to be the base area. So, and in between them, it's the neutral substances area. Okay, so we have acids, neutral, and bases. Okay, so here's another scale. So at this area here, strong red color, we have strong acids, dark purple, strong bases, and between them we have the neutral substances. So the midpoint is 7. We can divide 14 by 2, so we did 7. So below 7 we have acids, and if the pH is greater than 7, the substance is a base. So pH less than 7 is acid, for pH equals to 7 is neutral, for pH more than 7 is a base. Okay, so let's note that in this case, so we have either we have no H plus nor OH minus, or we have as much H plus as OH minus, like in water, H2O. Okay, so this is how you get a neutral substance, perfectly neutral, balanced substance. Okay, so we have lemon here, has a pH of 2, tomatoes 4, so tomatoes is weaker than the lemon. So then you go to the milk, pH equals 6, still an acid. Water 7. Now antacid, which has a pH of 10, it's kind of a weak base. Then households ammonia, pH equals 11. Drain cleaner, which contains NaOH, is a very strong base, has a pH of 13. Okay, now to use the pH scale, we can use the pH paper. So here's the scale, goes from 0, 1, 2, 3, 4, 5, 6, 7, and it's supposed to be on the other side. So we have 8, 9, 10, 11, 12, 13, and 14. Okay, so you take this paper, dip it in a solution, and start comparing each square to the reference here. So for example, if you take this paper, dip it in the solution, and you got like these colors, this means that the pH is 1, means you have a strong acid. If you got like these colors after comparing, means the pH is 5, and so on. Okay, so a pH paper changes color with an acid or a base. So this is the color chart. Okay, you can use it to determine the pH range of a substance. Now for the pH meter, the pH meter gives the exact value of the pH. Okay, once you dip it from this end here in the solution, it will give you the exact pH of the solution. And since you know what is the range of each solution, so let's say for example 7 and 1100, so this means we have a base because it's greater than 7, okay, and so on. Okay, so it is an electronic device used for measuring the exact pH. Okay, it's not like comparing colors, it's more accurate. So as the pH paper only results in a pH range, so using the pH paper you can determine like roughly the pH. Okay, now again the pH scale, so it goes from 0 to 14, from strong acids up to strong bases. Okay, so that's it for acids and bases. So now we're gonna move on to this table. So acids taste sour, bases taste bitter, and they're slippery. So with water, acids release hydrogen ions, bases release hydroxide ions, which are the OH minus. With litmus paper, so acids turn blue litmus paper pink or red, so they don't work with the red litmus paper, and the bases work only with red litmus paper and turn it into blue. The pH of acids is less than 7, the pH of bases is greater than 7, and for a neutral solution the pH is 7. Okay, we can put some examples here. We have hydrogen chloride, which is a strong acid, H2SO4, citric acid, and we have here an AOH, sodium hydroxide, we have the ammonia, and many others. Now what happens when you mix an acid with a base? So what happens is that a chemical reaction will take place and you will have a formation of salt and water. Now the thing is that when an acid and a base of equal strength are mixed together, they react and will form only salt and water. So only salt and water, this means that the result is a perfectly neutral substance, right? Why? Because the acid and the base were equal strong. How? Again, a strength of an acid is determined, by the amount of hydrogen ions it releases, right? So if you have as much hydrogen ions as hydroxide ions, so each one will combine with the other and they will cancel each other. So each hydrogen ion will combine with a hydroxide ion and the result will be a water molecule, right? So H plus OH minus equals H2O. Let me write the equation here. Okay, so this is why in the result you don't have neither hydrogen ions nor hydroxide ions. So the result or the resulting substance will be neither an acid nor a base. So this is why it will be a neutral substance. Why? Because the acid and the base were equally strong. Okay, so such reaction is called a neutralization process. Why? Why do we call it neutralization? Because simply out of two substances, out of an acid and a base, we made a neutral substance. Okay, so neutralization because the resulting substance is neutral. Okay, now as I said, the result of a neutralization reaction is salt and water. So let's check the properties of salts. So we're gonna identify some common salts and their usage. Of course, not all salts are sodium chloride. Sodium chloride is not the only salt in the world. And we're gonna explore what is a neutralization reaction, just as we did, and we're gonna recognize that salt is formed by ionic bonding, and to understand electrolytes. Okay, what electrolytes are. So let's start with salt. So every salt is a compound, so we have more than one type of atoms formed by a reaction between an acid and a base. Okay, so every time you mix an acid and a base, you will get salt and water. Okay, so a special case when the acid and the base are equally strong, you will get a perfect neutral substance. Yes. Okay, if the acid is stronger than the base, like let's take this case. So if you have more hydrogen ions than hydroxide ions, let's say we have this much hydrogen ions and we have a little bit of hydroxide ions. So this hydrogen will combine with this hydroxide ion. Let's take this hydrogen ion with this hydroxide ion. So we're gonna have, as a result, 2 water molecules plus 2 hydrogen ions. So in the result you will still have hydrogen ions, which means the resulting solution is an acid. The same happens, or the opposite happens actually, when you have a stronger base. So you have more hydroxide ions this time than hydrogen ions. So these two will combine, so you will have 2 water molecules plus 2 hydroxide ions. So in the result you have a solution which contains hydroxide ions, which means it's a base. But only if the acid is as strong as the base, you will have a neutral substance. Okay, but in all cases, in every case, it will be salt plus water. Okay, let me erase these. So one example of neutralization, if you take HCl, which is hydrogen chloride, plus KOH, so you have hydrogen in the first place here and OH in the second place. So what happens is that the near element will combine with the nearest one. So in this case chlorine will combine with potassium and the far ones will combine together. Okay, so H is combining with OH, so H plus OH minus leads to H2O, or you can simply write it without the plus and minus signs. Okay, so we have 2 hydrogen atoms, 1 oxygen atom and 1 oxygen atom on the other side, and chlorine will combine with potassium, so K plus Cl will lead to KCl, potassium chloride. So in this case, potassium chloride is the salt and the water is the other product. Okay, so hydroxide ions of the base combine with the hydrogen ions of the acid, and they will lead to the formation of water. Okay, so the other atoms of the acid and base combine together. So every time you have a neutralization reaction, always remember that hydrogen needs to combine with hydroxide. Okay, always, every time hydrogen combines with hydroxide, and whatever you have left, whatever elements you have left, to combine them together. Formation of table salt. So if you take hydrogen chloride as an acid and mix it with sodium hydroxide, so as we know, hydrogen will combine with hydroxide and the rest will combine together. So H plus OH will give you water, H2O is water, and sodium plus chlorine will give you sodium chloride, NaCl. Okay, so H plus, because you know it's an acid, so it releases H plus hydrogen ions. OH minus, because it's a base, it releases hydroxide ions, so they combine together, and the chlorine will combine with the sodium. Okay, so the result will be sodium chloride, table salt plus water. Now for the ionic bonds, so let's remember that an ionic bond is formed when one atom takes an electron from the other one. So it's a bond that's realized by giving or gaining and losing electrons. So in sodium chloride, what happens is that the chlorine here has a negative charge, so it has one extra electron. But sodium having a positive charge, which means one less electron. So a sodium atom loses one, the chemical bond is formed between the two atoms. Okay, so the positive charge of sodium attracts the negative charge of chlorine, and the two atoms will come together and combine, form an ionic bond. So this is salt, and this is the structure of salt. So this is how chlorine atoms and sodium atoms are brought together. So where can we find salt? Obviously at the sea, and salt sometimes is found as rocks like Himalayan salt. It has salt and of course other minerals with it. So the use of salts, we use them in food, we use them in melting ice on the road, because if you add salt it will decrease the freezing point of water. So the water is supposed to become cooler now to freeze the water, so when you drop the freezing point. So this is how you melt ice using salt. Preserving food, as you can see here, and many of course other uses, like magnesium sulfate is used in bath to smooth muscles. Other salts like silver bromide, here AgBr, is used in production of photographic films. So this is the color before casting light on the salt, and this is the color after casting the light. Okay, so the salt changed its color, so you kind of have a picture now of, formed on the salt. Barium sulfate is another salt. It's used in X-ray, to visualize the internal organs. Now, salt in liquids. So many salts, that many salts can dissolve easily in liquids. But the most important thing about these salts, that once they dissolve in a liquid, they will release their ions. For example, sodium chlorine. If you dissolve it in water, it will release sodium ions, Na+, and chlorine ions. So these ions have electric charges. So these ions will allow electricity or an electric current to flow in the liquid. So this is why they allow the flow of electric current in the solution. Okay, so once they are dissolved in the liquid, they are now called electrolyte. So electro from electricity. Okay, so electrolyte let the electric current or let electricity flow. So if you take distilled water, distilled water, it's just H2O. So H2O, pure H2O without any minerals in it. Okay, so distilled water contains no ions. So you have just these H2O molecules, you don't have any ions here. So if you try to open an electric circuit inside using distilled water, the current won't flow. Okay, why? Because there are no ions in it. But if you dissolve a salt in it, so you're gonna have a pluses and minuses, you're gonna have a positive ions and negative ions, and so electricity will flow. So this is it for now. Thank you and good luck.